Hi, today we'll be discussing about the tech stack required to build any system in a software development life cycle. Uh, we have a standard tech stack to build any kind of system. If you want to build any website or a backend system or any asynchronous messaging system or any other system application or anything, so you need to decide the tech stack first when you are designing the when you want to build something based on the requirements and feasibility. You have to come up with the tech stack design. It is very important thing when we are building an application or any system. We generally consider this step as part of the system design and architecture. We will list down all this architecture and tech stack details in architectural document or system design document. We specify that, and you can see whenever you are building any application, the we have to divide things into majorly, the parts like this. Front end design, the first part is the front end design. When you are designing a application, you have to come up with the user interface, user design, right? Based on your requirement, how friendly is the user interface, your website design basically. So nowadays we are seeing a lot of websites and user designs, user interfaces, multiple UI and UX designs. We are seeing it, right? So you need to come up with the most standard and flexible, user friendly, and user based on the usability. Also, you need to come up with the UX design. After that, you need to select the front end design technology. For designing a front end, we do have frameworks along with the HTML, CSS, JavaScript. Along with all these, technologies, we do have frameworks. Like you take a React JS nowadays. Most of the companies, they are using React JS and UJS, Angular JS for complex UI applications. For for styling, and we have a CSS, Bootstrap, Tailwind CSS. So many things are there. In general, we also have a JavaScript. Also, you can use. We have Ajax and jQuery. So many front end technologies are there. If you want to build anything, so you can see the diagram here. Basically, the users are first, they'll interact with the front end, user interface. After that, request will go to the back end. A backend means the backend application where it will be deployed. Web server is the server where you deploy your backend application, and it may interact with the file system. It may also interact with the database for fetching the data. So now, let me explain the backend server. Now we have a backend, front end application ready with. Now what we have to do, when request comes from the front end, it will go to the backend server. Backend server, which actually handles the logic, right? Your application has to handle the logic. So backend server, generally, the backend application can be developed by many backend programming frameworks. You can take Node.js or Python, Java, Spring Boot, Spring Framework for enterprise applications, or Go. There are many programming languages are there for building a backend application. You can also call it as a middleware, basically, but you see it that way. You can develop it, and you need to deploy this um, both backend and front end application. Generally, backend applications we will deploy in application servers. You can name them as a WebSphere, WebLogic, Tomcat. So many enterprise level application servers are there. A front end application you have to deploy in a web server. Most of the time we use an Tomcat, or so many are there. But both front and back end generally deploy in the same servers. um, So we need to mark that. And other thing is the database, right? So database is generally for storing application data. We will generally store the data for any domain. You take healthcare domain, banking and financial systems, so they'll store customer data, transactional data, notification related alerts, so many the detail generally stored in the database. So we definitely need a database. We can also use the file system for storing some files, for accessing files from the file system. But most of the time, the backend application will interact with the databases. We do have two kinds of databases in the market. Majorly, we can see one is the relational databases, SQL, structured query language. Uh, Generally, we store the structured data, the data which is proper, transactional data. You can take customer data, demographic information, or personal data, any data which is having some kind of structure, which can be normalized, which can be stored into tables, normalized tables, where we can establish a relationship among the tables, and we can enforce some constraints as well. You take a foreign key relationships, or you take a unique constraint, check constraint. So many constraints are there with respect to relation, the structured query language. We can also, so you can see so many for examples of relational database. Oracle is one of the examples, and Postgres, SQL, MySQL, Sybase. So many relational databases. DB2 is IBM provided vendor database. I can consider many databases are there if you want to use it. Okay, and NoSQL database, it was introduced later in the mid, you can see 20s, where you see here, uh, you can see the MongoDB, one of the best example. Why do I need NoSQL databases? Because it is not a structured data that we store in this database. It is unstructured data. It is a kind of semi-structured data. It can be some kind of JSON documents, or it can be Excel sheets or Word document. It can be video files, audio files, anything. You can consider, you can name it as a unstructured data. So based on the type of the data, you can choose any NoSQL database. Why we introduce NoSQL data? Because the speed is important factor here, rather than uh, normalizing the or creating the database schema. Because we don't need to bother about structuring or normalizing the data. We don't need to bother about atomicity of transactions. We only bother about how fast we can store or how fast we can get it. If that is our concern, then we can choose any database. So there are so many databases in the market, NoSQL databases. One of the examples is MongoDB. Mostly we use MongoDB for storing log data, for logging purpose, and Cassandra DB, key value column oriented data. And we have a graph databases for storing graph related information. And we have what is that, so many, Hive DB, for the big data handling. So many databases are there. You can choose any NoSQL databases. Other important point is authentication and authorization. How you can secure your complete system once you create it, right? So you need to pick up some security framework for integrating that in for your application. We have many security authentication and authorization mechanisms in the market. So many third party services provided are providing the security frameworks. You can see Auth0, Firebase authentication, Okta. The major thing is OAuth 2 concepts: OpenID Connect, role-based access control, LDAP. These are the security framework most of the time we used. JWT with backend implementation. JSON Web Tokens is also one of the great concepts for building distributed and microservices based architectures application. You can actually consider this. So once you secure your application, other thing is how you deploy your application into server. Either you follow SDLC or Agile framework, Agile methodology, or any iteration sprint model you follow it for developing application. You need to take care of a deployment process, right? Release management is very important thing software development. So how do you handle the release management? Infrastructure and deployment where your application runs. Basically, you need to deploy into a server. As I told you, you will have a servers, right? You may have a WebSphere server, WebLogic server, Tomcat, or you can also deploy in cloud provide any cloud. Because they'll provide servers, right? Scalable servers. You take AWS, Google Cloud, Microsoft Azure. You can actually deploy them there. How do you deploy it? You can either containerize your application or you can directly deploy your application like artifact. You can deploy a jar file or war file or enterprise file, enterprise application. The best approach is dockerizing your artifact into image and then deploying that into cloud or cluster, given it is cluster. Nowadays most of the um, companies, and they are using this kind of model for deploying. They standardize the DevOps approach. A separate team will be there. They'll take care of this deployment of the applications and everything. So CI/CD, continuous integration and continuous deployment. You see, you have to continuously integrate your changes to the repository, and as soon as you check in the code immediately, there will be other Jenkins jobs or any other DevOps pipelines. They'll be triggered by this event, and they'll download that code, latest code, and they'll build the application, and they'll create image. They'll deploy that image into staging or production server. So you need to remember this. So you can build these pipelines in staging region, or you can also build in production region. Just do remember that you can build the pipeline using either any scripting language, or you can also use built-in tools, Jenkins, GitHub Actions, GitLab, CI. So many are there. You can do that. Okay. This is very important. Other key features and tools are APIs. APIs. How do you build API, application program interface? We need to design the flexible RESTful APIs. You can use REST APIs, or GraphQL is one of the best feature. You don't need to fetch all the data. You can only fetch only required data using GraphQL if you can integrate with the any REST API. Real time, for chat and live updates, you can use a socket. For searching, for implementing searching and all, you can also use Elasticsearch. So many searching frameworks are available. For implementing caching mechanism, we do have a Redis database, Memcache, EHCache. So many options are there. You can actually integrate with the caching, monitoring and logging. I say we do have so many applications for monitoring and logging. One of the best applications: Datadog, Prometheus, Grafana, ELK Stack, Kibana. So many monitoring system softwares are required. We need to monitor when we deploy large scale applications, enterprise grade applications in servers, right? It is very important. You see the popular stacks in the market. Mean stack is one of the popular stack. You can build entire application using only Java script based frameworks. You don't need to use any other language. That way it will be faster when you run simple applications, right? Python, Django, Java, Spring Boot is one of the great framework nowadays. Most of the applications are being built using a Java Spring framework. So, how do you choose these projects? You can see project needs, team skills, scalability, maintenance. So many things are there. But just remember, whenever you are designing a system, you need to take care of all these components into consideration. All these topics I have to make sure, based on the the business requirement, and I have to come up with the design with the tech stack are required to build an application, right? That coming so deciding the tech stack is also important factor in software development life cycle. So generally, most of the time, architects or other people, be product owners or business analyst or solution architects. So they'll decide the tech stack before they are coming up with the design of the complete system. So just do remember this, and I hope this video would be so helpful for you. And thank you for listening. Thank you very much.